So this learning guide is called Introduction to Quadratic Relations, and finally we are going to get to encounter quadratic relations. And so this lesson here is simply called Quadratic Relations, but this is the lesson where we we want to do two things here. We want to be able to recognize quadratic relations from their equations, their graphs, and their table of values. And that's what we're going to do in this first part of the lesson, or this first video. And we're going to compare them to linear equations that you worked with in the early part of this course, and you worked a lot with in grade 9. The other thing we want to be able to do is identify the key features of the graph of a quadratic relation. And this stuff we're going to save to till the second part of the lesson. So first off, just to sort of find our bearings here, we're going to talk a little bit about linear relations. And if what we want to do is we want to be able to recognize a quadratic relation from its graph, its equation, and its table, let's just look at how we do the same thing with linear relations that we're more familiar with. So let's start with the graph over here. Over to the right, I've got a graph of this equation, y equals negative 2x plus 4. And just by looking at the graph, we know that this is the graph of a linear relation because the graph is a straight line. Graph, let's spell graph correctly. Graph is a straight line. That's how we know it's linear. Okay, linear just means it's a line. Okay, so looking at the graph, we know right away that it's a linear equation. If we come over here to the equation, we can tell from the equation that this is the equation of a straight line. First off, we can see that this is in y equals mx plus b form, which we know is the form for the equation of a line. But we can also look at the exponents that we have on the variables in this equation here. So if we look at our x variable here, the exponent here is a 1. And anytime we have a linear relation, the exponent on x is going to be just 1. So we could always recognize linear equations when we saw them. Finally, if we look at the table of values for this same relationship here, you did this last year in grade 9, we could tell from the table of values that this was a straight line by calculating what were known as the first differences. Now, to do the first differences, what we did was we looked in our table of values, we went to our y values, we started at the bottom of our table, and we subtracted the lowest value, negative 2, from the one above it. Negative 2 minus 0 gives us negative 2. And then we worked our way up the table. The next value minus the one above it. So 0 minus 2, negative 2. 2 minus 4 gives us negative 2. 4 minus 6, negative 2. 6 minus 8, negative 2. And these first differences are negative 2 every single time. So because the first differences are all the same, this is a linear relationship. Therefore, linear. Okay, and this kind of makes sense with this is consistent, I guess, with what we see in the graph. In the graph of a linear relationship, if our slope here is negative 2, what that means is, negative 2. What that means is, as we pick a starting spot and we go over 1, we have to go down 2, negative 2, and then over 1, down 2, and then over 1. All right, and that's the same thing that we see in our table. If we go over 1 from 1 to 2, or over 1 from 0 to 1, from 1 or 1 to 2, our y values are going down by negative 2 every time, and that change in y and that change in x are the same. Okay, which is why we have a constant slope in a linear relationship. This is all well and good. We already knew all this stuff. What about a quadratic relation? Okay, so we can recognize a quadratic relation from the equation as well. A quadratic relation contains a polynomial of degree 2, which means the highest exponent on x is a 2 in our equation. So in general, a quadratic equation looks like this: ax squared plus bx plus c. And the fact that this exponent on x here is a 2 tells us it's quadratic. Exponent on x is 2. Okay? This makes it quadratic. So if I had something like y equals 2x squared plus 3x plus 7, and I asked you if it was quadratic or not, you would look at this exponent of 2 on here and you would say, aha, this is going to make it quadratic. But if I gave you something like y equals 3x plus 7, you would say, oh, the highest exponent that I have on an x is just a 1. This has got to be a linear equation. So we can recognize quadratic equations from the equation. We can also recognize them based on their graph. Okay, so obviously here we have a quadratic relation, y equals 2x squared minus 2. We know it's quadratic because of that power of 2 on the x. We're going to go ahead and we're going to graph this quadratic relation. Okay, so I'm going to take each of these x values in our table, I'm going to sub them into y and sub them into the equation and find the y values. So for our first one, we're going to have y equals 2 negative 2 squared minus 2. Remember, we have to do order of operations when we're evaluating things like this. We have to do the stuff in brackets first, but then the exponent, so negative 2 squared is going to be negative 2 times negative 2, which is a positive 4. And then 2 times 4 is 8 minus 2 is going to give us 6. Same thing for the next one. And this is especially true with these negative x values. Negative 1 squared is going to give me positive 1. 2 times 1 is 2, minus 2 is 0. And I can keep working my way down my table here. This one is going to be easy because 0 squared is going to be 0, times 2 is 0, minus 2, negative 2. Now I'm into positive values. So this one, let's just say I put it into my calculator. I did 2, 1 squared minus 2 is going to give me 0 again. And for my last one here, y is 2 times 2 squared minus 2. I get 4. 4 times 2 is 8. 8 minus 2 is going to give me 6. So let's plot these points here. Negative 2, 6 is up here. Negative 1, 0 is down here. 0, negative 2 is down here. 1, 0 is here. And 2, 6 is up here. So if I draw a nice smooth curve between these points, here is the graph of my quadratic relation. And quadratic relations have a very specific shape in their graph. This is called a parabola. Okay. What do we mean by parabola? Well, it starts up high, it comes down, then it has this point where it turns around and it goes back up again. Okay. They can also start down at the bottom, come up, turn around, and then head back down again. Either way, all of these parabolas have the same shape. They go in one direction, they have a turning point, and then they go back in the other direction. So we can easily recognize a quadratic relation from its graph. What about from a table of values? Well, we used first differences when we were talking about linear relationships. With quadratic relationships, we're going to have to use both the first differences and what are known as the second differences. So this is the same table we were working with on the previous page. We know that this is a quadratic relation here. Let's go ahead and calculate our first differences. So we're going to start at the bottom, and it's the lowest number minus the one above it. 6 minus 0 is 6. And we just work our way up. 0 minus negative 2 is going to give us 2, positive 2. Negative 2 minus 0 is negative 2. 0 minus 6 equals negative 6. So right away we can see that the first differences are not the same. First diff, I'll just say diff rather than differences, are not the same. This means our function is not linear. Okay, when we did our example for a linear relationship, all the first differences were the same. This is showing us the fact that the first differences are not the same shows us that this is not a linear relationship, which we know because we know it's a quadratic relationship. To prove that it's quadratic from the table, we have to go ahead and calculate what are known as the second differences. And to get the second differences, you do the same thing as you did with the first differences, only you're working on those first differences. So I'm going to start at the bottom of my table with my first differences, and I'm going to do the one at the bottom minus the one above it. 6 minus 2 is 4. And I'm just going to work my way up the table. 2 minus negative 2 is 2 plus 2. That's 4. I'm going to go up one more. Negative 2 minus negative 6. That's like negative 2 plus 6. That is 4. So what I notice here is that my second differences are the same. Therefore, this is a quadratic relation. Okay? For it to be a quadratic relation, the second differences have to be the same, and the first differences have to not be the same. Okay? We have to have both of those things happen. Okay? So, to finish off, a little summary here, okay? We can recognize quadratic equations from their equation. The highest power is an x squared term. From the graph, it has the shape of a parabola that goes one direction and turns around, comes the other direction. And from the table, the first differences are different, but the second differences are the same. So finally, here's one to try on your own here. We've got a table. Determine whether the following table of values represents a linear relation, a quadratic relation, or maybe neither of those. Maybe it's nonlinear and non-quadratic. So give this a try by calculating your first differences and your second differences and see what you get. You could pause the video here and try it and then check your solution. So I'm going to start with my first differences. I'm going to start at the bottom of the table and work my way up. 1 minus 0 is 0. 0 minus 1 is negative 1. 1 minus 4 is negative 3. 4 minus 9 is negative 5. My first differences, negative 5, 3, negative 1, and 0, are not the same. So it is nonlinear. Let's take a look at our second differences. Again, we'll start at the bottom and work our way up. 0 minus negative 1 is 1. Negative 1 minus negative 3 is 2. Oh, I got to go back and fix this. Oh my goodness. All the way back here, I did 1 minus 0 equals 0. That's not true. I'm going to change that. That should be a 1. That changes this first difference, the second difference over here. That should be 1 minus negative 1. And that's going to give us 2. This makes more sense. And now I'll keep working up my table here. Negative 3 minus negative 5 equals 2. Okay, so my second differences are all the same. Quadratic. Quadratic. And we could say something like, because second differences are the same. So if you're following along, yeah, make sure you go back and correct my bad subtraction there. Happens to the best of us. Okay, and that's it for now. In the second part of this video, we'll take a look at some of the key features of those parabolas that make up the graphs of our quadratic relations.